Okay, this is the last section in Unit 7. When we first started, I showed you those special patterns that we used for multiplying by two binomials. Now, as I promised, we're going to undo that, and I'm going to show where it was super helpful to memorize those patterns because this will go super quick then. All right, so factoring a perfect square trinomial. So this is not perfections. It should say this must have two perfect squares in the trinomial. It can only have one negative. Neither of the squares can be negative, so your center term has to be negative. This factors into this pattern. So I'll show you some examples. So number 1. So y squared is a perfect square and 4 is a perfect square. So we know we can use this. We have a positive, no negatives. So you're going to take the square root of y squared, which is y. The middle sign is plus the square root of 4 and square it. So we know we can check it because y plus 4 times the quantity of y plus 4. When you multiply it, we end up right back here. Okay? So if we know that this is a perfect square trinomial, meaning A is a perfect square, C is a perfect square, and the middle is 2 times the product of A and C, you can use this without thinking about it. So A for number 2, f squared is a perfect square, 64 is a perfect square, and negative 16, there's only one negative sign, so I'm going to take the square root of f squared, the minus in the middle, so I'm going to use that, square root of 64, and then I'm going to square that quantity. Number 3, A is a perfect square, C is a perfect square. So I have the square root of x squared, the plus sign in the middle, an addition sign, square root of 144, and we're going to square the quantity. Number 4, always check for greatest common factors. We don't have one here. W squared is a perfect square, 36 is a perfect square, one subtraction sign, square root of w squared is w, square root of 36 is 6. We're going to square the quantity. Now, if you look at 5 and we check for a greatest common factor, you can pull out a greatest common factor, which is 5 here. So if we pull out 5, inside I have x squared plus 2x plus 1. So x squared is a perfect square and 1 is a perfect square. It's often overlooked, but it is a perfect square. So I have 5, square root of x squared is x, square root of 1 is 1, and I'm going to square the quantity. Number 6, look for the greatest common factor. Here you can pull out 4. If I pull out 4, inside I have p squared minus p plus 4. So let's check what's in there. Again, A is a perfect square, C is a perfect square, so I can factor that to be p minus 2 squared. All right, now factoring the difference of two squares. This only applies to the difference, not the sum, and we're going to, they're going to try to trick us with that. So this is in here twice, must have been important. Must have two squares and only two squares. Must have one negative sign. You have to have that. If it's a positive sign, you can't do this. And it factors into the square root plus the square root times the square root minus the square root. And I'll show you what I mean. So these are two perfect squares. There's a minus sign in the middle. The square root of 16p squared is 4p. Square root of 1 is 1, so 4p minus 1, quantity 4p plus 1. These are both perfect squares. It's a binomial. It's a difference. Square root of 81x squared is 9x. Square root of 25 is 5. Now I'm going to use the addition for the other one. 2 squares, it's a difference. Square root of 4x squared is 2x. Square root of 121 is 11. We're going to do 2x minus 11, quantity 2x plus 11. So if you have this pattern memorized, you're not even going to have to think it through. 36y squared minus 36. I would say you have a greatest common factor of 36, so I'm going to pull that out. So I have 36. Now these are 2 squares. Y plus 1, quantity y minus 1. This is a 3, 36. Number 5, we can pull 2 out of there. So if I do that, I have 2 on the outside and k squared minus 16 inside. So difference of 2 squares. So I have 2k minus 4, quantity k plus 4. So I took the square root of k, square root of negative 16, and followed our pattern backwards. Number 6. There is a greatest common factor. It's 16. So 64 divided by 16 is 4x squared y squared. 16 divided by negative 16 is negative 1z squared. All right, same thing. We're going to take the square root here, minus the square root, same square root, plus. These are z's, not 2's. Okay? Get rid of this. One more. So I have 100m squared plus 25. If I look for the greatest common factor, I'm going to pull out 25. So I have 4m squared left plus 1. Remember, 1 is a perfect square. So I'm going to have 25. Oh, it's addition. So this pattern up here only applies when you have the difference. So this is as far as I can get. Okay, that's it.